Presentations with Microsoft PowerPoint can be excellent for teaching, but I prefer web pages because they link to the internet much more easily. With PowerPoint, you simply click and move on. With interactive web pages, the viewer is forced to learn something. This figure was found on the internet at the URL shown at the top. It is accompanied by excellent explanations and more figures. This is the interactive graph that is the focus of this video. This is active learning. The student can set initial conditions and use the sliders in the lower left corner to get a full grasp of what's happening. You should use your internet browser to go to the URL at the bottom of this page. That way you can select the various programs and follow along by stopping and starting this video. Let's examine this web page briefly. It uses colors and comments to indicate some of the subroutines that are available as templates. When you use the sliders, the display switches to this, which is the simulation of the chemical reactions that we looked at before. Note the little circles in the blue line, which resulted from selecting a step size for integration that was too large. Please click where indicated by green arrow 2. This is a typical session for the student. It comes up with a page where you can set the initial conditions. If you then go to the slider bars and start tinkering with the coefficients, this display comes up. Many permutations can be investigated quickly. By clicking any place on the canvas, you return to the panel for the initial conditions. And then going back to the sliders, again we see the graphs of the equations. This is a quick review of how to capture source code. Use Ctrl-A to highlight the source code and then copy it to paste into your text editor. To do your own interactive graphing, go to the subroutine Plot'em and substitute your equations for mine. You will probably have to go to the function stubs as well in order to get the different numbers on the axes. It doesn't matter much that this example has a terrible integration scheme because it accomplishes its teaching objective. Here's an example with no differential equations and no need for setting initial conditions because the plot starts at 0. I hope that you found entertainment and inspiration with my help menu. Please join me in this crusade to make web pages do something. Thanks for watching.